Hello students, today we're going to be continuing our lessons on probability. Let's go ahead and start with this warm-up. Pause the screen and go ahead and complete these problems. So using a deck of cards, find the probability of the following events. So thinking about our deck of cards, you can bring that up right here. And so let's think about the probability of getting a 3 or a 5. So look at how many 3s there are. There's 4 3s, so that's 4 out of 52. And since it says or, we're going to add the probability of getting a 5. There are 4 5s. So when we add those up, we get 8 out of 52. Always reduce to lowest term, so we can divide those both by 4. So that would be 2 out of 13. And if the problem asks for the percent, we just type that in, so 2 divided by 13. And it looks like 0.153, so that's about, we're going to put 15%. Okay, and looking at number 2, the probability of getting a red jack or a 4. So for red jacks, it looks like those are right here. There's 2 red jacks, so that's 2 out of 52. Or, so I'm going to add 4s, there are 4 4s, so 4 out of 52. And keep in mind, when you have this deck of cards, you're not trying to choose all 4 4s or all of the red jacks. You're only picking one card out of the deck of cards. We're just trying to calculate the probability that the card we pull out happens to be a red jack or a 4. So that's 6 out of 52 when we add. Looks like we can divide those both by 2. So we'd get 3 out of 26. And our percent, so 3 divided by 26 gives us 11, about 12% if we round up there. So we'll write that as 12%. Okay, looks good. So today, at the end of this lesson, you should be able to explain independent versus dependent events, the difference between with and without replacement, and also calculate the probability of different events involving and. Yesterday we talked about or, and today we're mostly talking about and. So take a couple minutes. You'll need to pause the screen to write down all of the definitions here. I'll go ahead and read them and then explain them a lot better as we go on to our examples. An independent event. 2 events are independent if the occurrence of the first event does not affect the occurrence or the outcome of the second event. So the probability is not changed. A dependent event. So 2 events are dependent if the occurrence of the first affects the outcome or occurrence of the second, so that the probability is changed. With replacement means exactly what it sounds like. Replace whatever was taken out. So if you have a bowl of marbles and you take a blue one out, if it says with replacement, you need to replace that blue marble, put it back in. And without replacement, you do not replace, so you do not put back in whatever was taken out of the total. So therefore, an independent event occurs with replacement. A dependent event occurs without replacement. So we'll go over this as we apply it to the problems on the next page. Okay, it says to find the probability of selecting players for a volleyball game. These are placed in a hat and picked out, so you can see the picture here. There are 4 left side hitters, 3 right side hitters, 6 blockers, and 2 setters. And I just abbreviated all of those just with the letter. So you can see in the hat, I put that there are 6 blockers, so there should be 6 B's in the hat. Left side hitters, so there's 4 L's, 3 rights, so 3 R's, and then 2 S's for 2 setters. Okay, so what is the probability of picking out of this hat a left and a right with replacement? So we're going to do 2 things. We're going to pick 2 of the players here. So this is different from what we did yesterday when we would just draw 1 card. This, we actually want to draw a left side hitter and then a right side hitter with replacement. Okay, so what's the probability of getting a left side hitter? So see how many L's there are? There's 1, 2, 3, 4. So the probability of getting a left side hitter would be 4 out of the total, which is 15 when we add all of those up. And it says with replacement. So imagine that we actually get this left side hitter right here. So we take him out. And it says with replacement. So I drew it out of the hat. Now I'm placing it back in. So the total is still the same. And it's a little different from yesterday. And means multiplication. So make sure you're writing this rule at the bottom. So now we're multiplying the probability of getting a right side hitter. So look how many right sides there are. There's 1, 2, 3. So we're multiplying that by 3 out of 15. And again, the total is still 15 because when we took this left side hitter out, when we drew him out on the first one, it says with replacement. So we put it back in the hat. So we're going to multiply these out. You can either use your calculator and type the fractions in, 4 out of 15 times 3 out of 15. Some students like to just multiply the numerators and denominators. Either way works with me, so I'm just going to do that and multiply straight across here. So 4 times 3 is 12, 15 times 15 is 225, and let me make sure I'm checking the math here. So 15 times 15 is 225, and now we need to divide. So 12 divided by 225 gives us 0.053, so that would equal 5.3%. So the probability that we choose out of this hat a left side hitter and then a right side hitter would be 5% chance. Pretty small. Let's do the same thing, this time without replacement. So what is the probability of getting a left side hitter and then a right side hitter without replacement? So same thing as before, we have 4 out of 15 because in this hat there are 4 left side hitters. So we take this out because we drew out the left side hitter, just like it says to do. And now it says without replacement. So I'm not putting the left side hitter back in, I'm going to keep him out here because I drew him out. And now what's the probability of getting a right side hitter? So there are 1, 2, 3. There are 3 right side hitters. The total is 14 though, because we did not replace without replacement of that first event. So really make sure you understand why the denominator here, the total, is going down since it says without replacement. You can see that this L is on the outside. Okay, go ahead and multiply straight across. So 4 times 3 is 12. And then 15 times 14, we get 210. And now dividing to get our percent, we have 12 divided by 210, and that's, let's see, 0.057. So that equals 5.7%. So you can see the probability, it's a little higher here for the second part because the total is less, because when we did not replace that left side hitter and the slip of paper is on the outside here, it raises our chance of actually drawing a right side hitter because there's less slips of paper in the hat left. Okay, number 3. The probability of getting a blocker and a blocker with replacement. Okay, so let's see how many blockers. It looks like in the hat there are 6 blockers, so that's 6 out of 15. Let me make sure I put that left back in there so we have the total. So if I choose a blocker, it says with replacement. So I will replace it since it says with replacement. So put it back in. And now what's the chance of getting a blocker? It'd be the same thing, 6 out of 15. So multiplying those out, we get 6 times 6 is 36. 15 times 15 is 225. And Doing the math here, we have 36 divided by 225. That ends up giving us 16. So that's exactly 16% probability that we would choose a blocker and then a blocker. There's a lot of blockers in the hat here, so that seems right that that's a little higher than we've seen before. All right, and let's actually do one more problem. Let's add this in. Let's do the same thing and do that without replacement. I want to make sure you guys understand the difference between the two with putting it back in the hat or keeping it on the outside. So let's do that same problem one more time. So the probability of getting a blocker would be 6 out of 15. So this time when you choose the blocker, so let me pull that B out of the hat, it says without replacement. So I'm not putting this blocker back in. So let me keep it right here just so you can see it. So now we multiply since it says and the probability of getting another blocker. So how many blockers are left? There's only 5 left. And the total is now 14. So notice how both the numerator and the denominator change because we're choosing a blocker and not replacing that first one here. So multiplying these out, we can do this part. Just make sure you guys get the right answer. We have 30 on the top. 15 times 14 is 210. And then we can divide 30 divided by 210. And that's 14% here. So that ends up being about 14%. And notice it lowered here because we took out that blocker. Okay, and looking at the very last one, let's first return that B here. So the probability of getting a setter and a left hitter and a blocker without replacement. Okay, so the probability of getting a setter, it looks like there are 2 setters. So that would be 2 out of 15. So let me grab that setter, and it says without replacement. So let me just put it over here. I can't put it back in. It says without replacement. Now what's the probability of getting a left? So for the left, there are 4 left side hitters, so that would be 4 out of 14 because the setter is on the outside here. And let me make sure I take that left and without replacement, so I keep it out here. And then lastly, a blocker. So for the blockers, there are 6 blockers, so that's 6 out of 13 because again, the denominator is going down since the setter and the left side are out of the hat. Okay, multiply these out. 2 times 4 is 8, times 6 is 48, out of, let's type this in, 15 times 14 times 13. That's 2,730. And then dividing this, we get 48 divided by 2730, and that's really small, 1.7. So let's just make, well, we can write that down, 1.7% here. Actually, if we're going to round, we might as well round correctly, so 1.8%. Very, very small chance that we would pick out a setter and then a left hitter and then a blocker in this order. Almost a 2% probability here. Okay, here's a you try. Go ahead and do these problems, and then I'll see you guys tomorrow.